If you sat down to write on a single piece of paper a crib note you could sneak into an exam for cheating, you'd do worse than the periodic table of the elements. And get this, they give you one in most chemistry exams. The periodic table is an essential tool in chemistry because it contains a vast amount of information that chemists use every day to do their job. As elements were discovered and isolated, early chemists began to notice patterns. Some elements could be grouped together because they had similar properties. They all reacted with water, or they all looked similar, or they behaved in recognizable ways. In 1869, Dmitry Mendeleev arranged the elements by mass and noticed that these similarities were periodic. Every so often, properties repeated. Every eighth element, for example, would react strongly with water. This was a stroke of genius, arguably the biggest single leap in the history of chemistry, because once periodicity was discovered, entirely new questions could be asked. What causes periodicity? Where are the missing elements? And later, where are the noble gases, predicted by the logic of the table itself? The modern periodic table isn't based on mass, it's based on atomic number, although the arrangement ends up very nearly the same as Mendeleev's arrangement. The columns, called groups, contain elements with similar properties. The rows, called periods, tell us how many electron shells an atom has. The S, P, D and F blocks describe the shape of the electron shells being filled. The atomic number tells us how many protons and therefore electrons an atom has. And the trends across the table tell us about reactivity, electronegativity and much more. The list just keeps going. It's entirely possible that humans will never produce a single one-page document containing more usable information than the periodic table of the elements. And it all started with a stroke of genius from Dmitry Mendeleev.